16. Bring it on up that. Test. All right, well, welcome everybody. It is Tuesday once again, and we're going to do some chemistry tonight. So it's awesome to be here with each and every one of you, just learning some of the things that we really need to know about pH tonight, because pH is going to show up on your exams. For everybody that was giving me feedback on the oxidation numbers guide, thank you so much. That's really helping me improve. So when we make it available to everybody, it'll be really helpful for them. I continue to work on that redox guide, and I gotta say, redox it's hard to learn, and that makes it a little bit difficult to teach. So I'm trying to be really careful and do my best. So your feedback is always helpful. Let's talk about pH though, because tonight we are going to, where are we? Here we are. We're gonna look at the pH of substances and talk about what pH means. We're also gonna take a look here and do some calculations, even a titration type calculation. We'll work on that, make sure you can do those. So that's where we're going this evening, about 30 minutes, and then we'll call it good. So let's see, where's the chat? I don't see anybody in the chat. Somebody's here, yeah? If you're in the chat, check in, say hello. And the first question that I have for you is, what is the pH of lemon juice, milk, and blood? And I'd really like you to drop in the chat what you think the pH of blood is. What is the pH of blood? It's kind of interesting. And then we'll actually test this here. All right. So let me jump over to, there's the chat. All right. There's Len and Isabella. Awesome. Loretta's there. Hey, Loretta, it's great to see you. Excellent. Excellent. Lots of folks here tonight. All right, so pH of lemon juice, milk, and hopefully you're going to drop the pH of what you think is the pH of blood into the chat there. So I'm going to move my camera over, and I have some pH paper. Let's actually test this. See if I can move my camera over here. I think I can do it. It's a little bit challenging. I need to get another camera. I need to get a really nice other camera here so I can just switch back and forth. All right. There's something. There we go. So this is probably the best I'm going to do this evening for you here. So what I have is some pH paper. And pH paper looks like this right here. It has a scale on it, so you can tell the pH of what we're working with. This is a Hydrion pH paper, and I'll just tear a piece of it off, put it right there. Let's get some more light on that. And we're going to put some lemon juice on it. All right, Loretta knows the pH of blood. That's pretty awesome. Isabella, you're close. If you had the pH of 7.5, you would be in the hospital, though, with alkalosis is what they would call it. Hey, New Beginnings, thank you. Very nice. Yeah, bipolar, you would also be in the hospital at 7.5. Alkalosis, your kidneys would start suffering pretty quick at 7.5. Lemon juice is around 3. Oh, I got to get a different thing. I'm going to just drop some in here. Let's see what happens with lemon juice. I got this out of my fridge. It's really old. So when I look at the scale here, if you look at the scale, you see 3 right there, like Loretta's saying, kind of an orange. And yeah, I think I'd agree with that. Kind of looks the same as our 3 here. There's 3, maybe even a little less towards 2. All right, that's lemon juice. How about milk? The pH of milk. And the milk should be pretty fresh this time, so we'll see. I'm just going to dip some pH paper in this milk I got here. There's my milk. And let's just put our pH paper in. And milk is, oh, I just dropped it in. It's gone. Another piece. Not doing so well. Try it again. Milk is kind of interesting. It's like green. So if you look at the pH paper here, let's move our milk out of the way. It's kind of like 5 or 6, maybe even, milk's maybe even higher than 6, but it's not 7. Milk's definitely not 7. And what they say, milk should be a pH of about 6.5. So I'd agree our pH paper is working pretty well. And I don't have any blood with me here today, so we're going to have to wait on that one. But the pH range for blood is 7.35 to 7.45. And if your blood goes any lower than 7.35, you're probably going to the hospital, much lower. And if it goes much above 7.45, you'll go to the hospital. And a lot of admissions to the hospital are because of problems with pH in your blood. Because you breathe in carbon dioxide, when that dissolves, you breathe in oxygen, and when your body uses it, carbon dioxide actually can create carbonic acid and some other things. So there's a link in the description of this video and a whole book about blood chemistry, especially if you're taking the MCATs there. You might want to look at that. So let's do some calculations here, because that's what's going to be on your test. Pikachu's ama, nice, I like that. So we said that lemon juice was about 3, right around here. Milk was right about here, and blood should be pretty much right here. So acid, base, and then 7, that's neutral. I'm pretty sure you guys know that. Hey, Igor, it is great to see you here. I'm happy you were able to figure the time zone out. So in the lab, that's what we use, is this pH paper that I was using. But if you're actually working in a lab as a scientist, you're going to use something like this, a pH meter. And a pH meter gets really accurate, like you can get like 2.44. You can do all kinds of things with a pH meter. You can even measure conductivity and things. So in the lab, at school, you might use this right here. But as a practicing scientist, I've never used pH paper. Maybe in the field, like if you're going out to check something in the field to see if it's, an acid or a base, that might work. But for serious research, probably using something like that. All right. So, give you a chance to try this one here. Figure out the pH of a 0.1 molar solution of HCl. You'll see something like this on a test. Take a moment and do that. When we talk about pH, this H right here, that's the H plus ion. That's what makes things acidic, is H plus. So HCl, when it breaks apart into H plus and Cl minus. And it's that H plus that we're really interested in when we're talking about acid chemistry, acid-base chemistry. All right, so no one's put the answer in the chat. If Jason was here, he'd put that in the chat, I'm sure, right away. pH, so negative log of 0.1, and it's 0.1. You have 0.1 molar solution of H plus and Cl minus. They broke apart, but they're still 0.1. That turns out to be a pH of 1. That's it, pH of 1. So pH of 1 is pretty acidic. More than our, what would you say, more than our lemon juice. Absolute 0 got it. But if I got pH 1 on my hand, like if I got this on my hand, I wouldn't be too worried. I'd just wash it off. You can actually have negative pHs. That's a little more worrisome. All right, let's try another one. Make this one hard for you. So you figured out the pH of the acid, but this is different. This is sodium hydroxide. This is a base. So you have to use two equations. Take a moment, see if you can get it. Yeah, Igor, you got it, man. So let's put this up here. $13. I'm going to have to do the math, but I think absolute zero, you may be onto something. So when we talk about 0.1 molar solution here, right, we have the sodium ions. This splits apart because it's a strong base. These are the strong bases. And then we have our 0.1 molar of the hydroxide. So yeah, we're just taking negative log of 0.1, which we know. We don't know this, but we do know this. We're looking for the pH, so we don't know this. We know that this right here, negative log of 0.1 is 1. So something plus 1 equals 14. That's it. So, and as you expect, the strong base would be right around 14. Yep, Abio, you got it as well. So these are the strong bases, and I would recommend that, I don't know if this is going to work here. Let's put it over here. If you notice these right here and all of these right here are in group 1. And these right here are all in group 2, I believe. So when these elements form bases, they're considered strong bases. That's a real good thing to know. Okay, so you can do that. What are we going to do here? Oh, we should do a demo. So do you guys like when I do demos, is that something that's interesting? Or do you like just doing problems? I would be interested in knowing that. All right, here we go. What type of reaction do we have? And there are two correct answers for this. So the first is that the H goes with the OH, that gives you H2O. The Na goes with the Cl, so that's a double displacement. But we have a strong, both. We have a strong base and a strong acid, so it's actually called neutralization. Both says flaming fin. Okay, neutralization, you got it. But it's also, neutralization is also a double displacement reaction here. So that's sometimes a trick question teachers like to ask. All right, Loretta and Len are saying both. Well, that's good. That's kind of what I thought. Yep, absolute zero, you got it. So what I'm going to do is, let me jump over here. I've got my pH paper. So I'm going to take my pH paper, I'm going to take a piece of it off here like this. And I'm going to put HCl on one side and sodium hydroxide on the other, and I want to see what happens when they meet. So we're going to see what happens when they meet. And think about that. What happens when those two things there meet together? So I got to move my camera again. All right, let's go over to my camera. All right, we should probably put it in a watch glass because these are pretty strong. I have a strong acid and a strong base. And I'm going to put some face protection on as well so I don't burn my face off. Could you imagine if I ran from the room screaming? What would you think? All right, so first I'm going to put some, let's put some acid over here. And you remember the acid should be kind of the red color. There it is. And then I'm going to put some base over here. That's kind of a blue color. Let's put some more acid on there. The race is on. Yeah, it should be neutral in the middle. And you might not be able to see it. There's a little bit of yellow right there in the middle of those. Getting closer on that. I can't get much closer without it flipping out. Whoa. There. But they're actually starting to see a little bit of yellow in the middle of it. So what I'll do is I'll put this here so we can see it. I was hoping to get a little bit better light. And we'll kind of let this go and watch and see what happens. But I think you can start to see the yellow there. Right between it. Certainly they've stopped. So let's let this go for a bit and see what happens. What I'm going to do is, if I do it like this, you can actually still see it in the corner there, maybe a little bit. Maybe. All right. So that's the type of reaction. That's our neutralization. And right there in the middle, you have NaCl, which is just salt, right? And H2O, salt water. So when we have that kind of place in the middle where they meet, the pH should be 7. So we have 1 and 14, but they're neutralizing each other. It's just salt water. So if you actually had an equal amount of HCl and NaOH, you should be able to pour them together and then drink it and not, it just tastes like salt water. But you better make sure your stoichiometric ratios are perfect or you're going to burn your tongue off. So, all right. So where are we at? What do you guys see? And there we are. So here's where it gets kind of serious in terms of chemistry. When we do a titration, we have an amount of, say, in this case, we have NaOH, and in a beaker, we have some HCl solution. So what we want to try to do is add a known quantity, and then when the pH changes, when it hits 7, so we put some pH paper or an indicator in, when it reaches 7, we know they're equal, and we can figure it out. And absolute zero, you're right, that neutralization, acid-base reaction, pretty similar. So see if you can figure this out. And we use molarity 1 times volume 1. Volume 1 equals molarity 2 times volume 2. This is how much we pour in the beaker, and this is how many milliliters we have in the beaker. Give that a try. This is one that every chemistry exam has something like this on it. Let's see. All right. So I'm probably not giving you enough time to do this, but I'm going to do it silently. You can continue working, and I'm just going to silently fill the numbers in. Although absolute zero, you're pretty quick. But did you think of your significant figures? So a lot of times students will ask me, does this have to be in liters? And if you think about it, the answer is that if these are the same, they're going to cancel out. So you can leave this in milliliters and it'll cancel out because our final answer should be molarity. So let's see if folks are right. Remember that if you have 0.15, you can only have two significant figures here. Absolute zero, you fixed yours, yeah. So I could divide each side by 42.1 milliliters here and over here. So that's gone, and then milliliters are gone. So it doesn't matter if we had it milliliters and liters as long as they're the same. All right, Magni, welcome, welcome. And so if you do the math here, you end up with M2 equals, what did I get? 0.127, but because we only have 2 digits right here, we're going to make this 0.13, and that's moles per liter. So if you're given 3 of these things, you can solve the other one. And typically that's what a titration is. You'll take a known solution, you know the volume, and you know the molarity, and then you have an unknown where you can add it until the indicator changes, and then you just solve for the last one. So that's really important. Abdil, make sure your significant figures match. You only have 2 significant digits here, so you can only have 2 down here. Yeah, Igor, you got it. So what time are we at here? Getting there. How about the last one? I'll move this up. Whoa. I'll move this up here so you can see it. But before I do that, there we go. Can you see the yellow now here in the neutralization reaction? So right there in the middle where they meet, it's neutral. We've neutralized it, which is pretty awesome. But let's put some more acid on this side just to see what happens, because hey, we're chemists. We gotta test a bunch of stuff. And then more base on the other side. Let the battle begin. Kind of pretty, kind of like some abstract art there. Okay, so give this one a try here. I guess I got to put the screen back up. There we go. Find the pH of the solution in problem 6. You may have to try to remember those equations we did earlier. Where's that at? All right. There we go. It's always so weird with modern art. You got it. It's always so weird with cameras because it's like if you move to the left, it goes to the right on your camera, and it's just still confusing. I'm sure actors are really good at that, but I'm not. pH. What did we say pH equals? pH, and this is the negative log of the H plus. That's why it's called pH, equals negative log of H plus. And the brackets, that means concentration, molarity. So you should memorize this equation. Of the pH of this molarity right here, absolute 0, I think that's what we're going for. What is that? Anyways, what is the answer? Yeah, every teacher nags about it. You're absolutely right, Igor, constantly. And you know, when we're working with things like significant figures as a scientist, it's the type of thing where it tells me how accurate your equipment is. And that's important. I need to know how accurate whatever, equipment you're using. So to me, it's just useful. But when you learn it in school, it just seems kind of pointless. Anyway, all right. We end up with, I'm getting 0.89. That's the pH. And Abil agrees with me, as does absolute 0. Well, that's reassuring because you guys have been right most of the time tonight. I think that's all I got tonight. That's about right. We're about right on time here. There's our modern art that we made. Excellent. So let me jump back up here. We'll leave our modern art for the galleries in New York. And let's see if I can put this back up here without. I'm going to change to my screen so I don't make you seasick. How does that even work? All right. I forgot how my webcam worked. Okay. All right. Then I'm kind of back. All right. So thank you everyone for being here tonight. Gen Chem, OChem, wow. Yeah, you should be right. OChem's tough. I will be back on Thursday. And folks that are doing the oxidation number feedback, thank you once again. I'm really excited about this redox guide because it's so hard to learn. And like I said, it's so hard to teach because of that. But I feel like I can do a really good job if I'm getting ideas from folks like yourself who have learned it or are learning it. And we can really create something pretty cool that people all around the world will use. I've got about 700,000 subscribers on my channel and about 250,000 views a day. So if we create this thing, it will be used pretty heavily. So excellent. All right. So back next Thursday. And as always, this is Dr. B. And thanks for watching.